Dear students, in our basic civil engineering course, today I am here before you the topic contouring. In our previous classes or previous lectures, we have discussed what are the basics that are being studied in surveying. We need to find out the location of different points. As all of us know, Earth's surface is not of an even surface. It has various ups and downs. And a method to find out the position of different points on Earth is nothing but a surveying. One of the widely used method is used in surveying is contouring. So in today's class, we'll be studying about what exactly is contouring, what are its components. I'll be starting with the very first definition that which you can see on your screens, that is contour line. Before starting into contour line, I would like to revise the point which we have studied in a previous class, that is what is reduced level. The height or elevation of a certain point on Earth's surface in comparison to the datum line or from the mean sea level is your reduced level. So what exactly is your contour line? It is nothing but it is an imaginary line passing to the points of equal reduced level. For example, if I am standing on 10 feet from my Earth's surface, on the Earth's surface, there are various people who are standing on 10 feet height, and some are on 8 feet and the others on 5 feet. So a line, imaginary line which will join all the people standing on the height of 10 feet. That is a point or a line joining all the points of same height or all the points of same reduced level. That imaginary line is called as a contour line. If I go technically, it is also defined as the intersection of a level surface with the surface of Earth. Thus, the contour lines on the plan tell us about the topography of that area. Mean, in short, whatever the height of the area can be identified or can be predetermined by locating the contour lines of a particular area. Again, I have repeated the definition so that you can revise. Here, I have given you an example of for a contour indicates centimeter that all the points on the line of that particular map. How, where we draw the contour lines? Suppose you have a plan of a particular area. So how are these drawn? On the plan, we may point out different points of different elevation or different RL. Then we'll be drawing the line in such a way that all the points having same RL, the same height would be connected with each other, and this would display a contour line. And a complete map, a complete drawing of all the contour lines of a particular area is called as a contour map. As you can see here in the figure on your screen, here is a mountain which is being shown. Now there are different heights of different points on a particular mountain. So as you can see, 500, I'll show you with a pointer. Here 500 feet, 1000, 1500 and so on. Similarly, see the diagram below. It is a diagram of my contour map or contour map. The lines here shown, which I am highlighting with my cursor point, these lines are nothing but the contour lines. So just see the contour line of 0. It is joining this point and this point. So what it means? It means that all the points which are coming on this line would be having the reduced level 0. Just see 3500. All the points which are coming on this particular contour, this one, this circular one, will have the height of 3500. In such a way, we draw a map showing the height of various points on the Earth's surface. This is nothing but my contour map, and the lines which we use to represent the height are called as the contour lines. Nextly, we'll be discussing about the contour interval. What exactly interval means? Even if we go roughly in a day-to-day life, interval means what? It is nothing but a gap between two certain periods. Similarly, in a contour map, the gap of height, you can say, the difference between the elevation of two contour lines. As here you can see, this one is of 20, this is of 40. So the difference in between them is 20. Okay, so it means what? That the contour interval here is 20. I'll try to recite the definition here. The vertical distance between two consecutive contours is known as contour interval. Vertical means what? The height-wise difference. This is a particular map for a suppose particular area. If you can see, at after every 20 feet I've taken the reading for my contour line, its elevation. Hence, here for this particular diagram, my contour interval would be 20 feet. This interval always depends upon the factors such as the nature of ground, the scale of map, and the purpose of survey. If I'm going for a rough survey, my contour interval may be 400, sorry, contour interval may be 50. But if I want minute details, I may take it as 5 or 10 also. So it completely depends upon the project, upon the area. Suppose I'm talking about a mountain who's having a steep slope. In that case, there's very minute difference at the points which are close to each other. So in that case, there's no need to have very small interval. I can go for a very large interval also. Now, our next definition for which we need to know before moving further in contours, that is the horizontal equivalent. The horizontal distance between any two consecutive contours is known as horizontal equivalent. In the previous definition, we have seen vertical. Now here it is horizontal. See this one. On the Earth's surface, not about height. Contour interval is related to the height of 2 points. Horizontal means the horizontal distance on Earth's surface between 2 points. See here, this point and this point. So this one is the horizontal equivalent. If will recite the definition here. Horizontal distance between any two consecutive contours is known as horizontal equivalent. It is not constant. It varies from point to point depending upon the steepness of ground. More the steep ground, less would be the horizontal equivalent. A question may arise in your mind that, ma'am, you're explaining me regarding the contours, contour line, or what is the use, what is the purpose as an engineer for of this particular topic. So here are a few of the specific uses which I have mentioned here. The very first and the very basic use is that we need to know the earth level, earth surface level for various construction projects such as roads, canals, railway lines. Hence, for this particular project, we need understanding the topography of that area. The contour maps prove to be very essential and useful. Next, to find out the possible route of communication between different places. Yes, the new nowadays, we are using different types of modes of transportation. Hence, we need to find out more and more options. So, this for that purpose, we need to study topography, and the contour map is the only, you can say, beneficial method of finding out the topography. To ascertain the indivisibility of stations, to ascertain the profile of the ground surface along the direction, to estimate the quantity of cutting and filling. Yeah, I would like to explain you a deep meaning of it. What is cutting and filling? Suppose I'm planning to construct a road on a particular site. The earth surface is not equal. I've already explained you that we have an uneven earth surface. So in that particular case, suppose Suppose I'm going for a straight area where somewhere I have a planar surface, I have a deep, and somewhere I have up. The portion which is above or up of my main baseline, I need to cut the surface over there, cut the ground. And the portion which is below my, you can say baseline, I need to fill certain material. Okay, so hence I've mentioned that the contour maps or contouring method is very essential to decide the amount of cutting and filling in case of embankment construction. Here are a few of the rules which we need to know before going for methods of contouring. The very first one, every point on a contour line is on the exact same elevation. I've already mentioned it. All the points on the same contour line have same elevation. All the contour lines generally don't intersect with each other except at certain exceptional cases such as in caves or underground passages. The contour lines always close to form an irregular circle, but sometimes a contour line extends beyond the map area so that you cannot see the entire circle. The elevation between any two adjacent contour lines of different elevation on a topographic map in the contour interval. Contour lines never cross one another except for one rare case where an overhanging cliff, just you can say uh, mountain-like areas where we have a cliff portion, in that case it may go for hangout. Our next topic in this particular lecture would be methods of contouring. We already know that what is contouring. To find out the points of different elevations, to join the points of equal elevation is nothing but the contouring. So how exactly it is being done? We'll be studying this in detail in a few other classes, but today I'll give you a rough idea. There are two basic methods of contouring. The very first method is direct method and the other one is indirect method. What exactly is the direct method? In the direct method of contouring, the reduced level of various selected points on the contour line are obtained and their positions are located. The contours are then drawn by joining these points. It is very accurate method, but it is slow and tedious. How? All the entire work of contouring is done on the field itself in the direct method of contouring. I'll find out different points. I'll find out the locations, locations and their RL. After knowing the RLs of different points, I'll draw the contour lines there itself. Hence, for this method, we need large time. We need more accuracy, and it is not possible for major projects, but yes, it is being possible for smaller areas where we need very fine details or a very superior accuracy is being required. Here, as I've said, that actually will go on the field, on the site, and will be performing all the tasks. Hence, for measuring the horizontal distances, we may be using chain or tape, and for the large area, I'll be using compass, theodolite, or plane table survey method. And for the vertical control, I'll be using staff or hand level may be used. Next, what is indirect method? Indirect method is the type of method in which I'll just find out the RL of different points, locate them, and then coming back to my office, I'll plot them on the map and then the contour maps will be drawn. These methods are less expensive, less time consuming, and less tedious compared to the direct methods. There are three different types of indirect methods. The very first one is grid or network, you can say. Second is cross-sectional method. The third one is radial method or the tachometric method. Here are the very important, you can say, difference point between direct method and indirect method. This question is may be asked in the RGPV exams also. The very first important difference is direct method is more accurate compared to the indirect method, as we uh, physically go and find out all the RLs and locate the contour on the field itself. Direct method is expensive. The indirect method is cheaper because very few work is done on the field, just all the work is done in the office. Hence, it is a cheaper method. Direct method is not suitable for hilly areas, whereas indirect method is possible for hilly areas. During the work, calculations can be done. Whereas in the indirect method, calculations are not required in the field, entire work can be done in your workstation or work offices. Nextly, calculation cannot be checked after contouring. Yes, this is you can say disadvantage of direct method of contouring. As I'm doing my work on the field, at the same time I'll calculating the values and drawing the contour lines. Hence, it cannot be rechecked. Okay, because we are finalizing it. Whereas in case of indirect method, the calculation can be checked at whatever point of time it is being required. Students will be discussing the types of contouring in a further classes. So thank you. Keep studying.